What's up guys, it's Gino, and for my science project, I'm going to be demonstrating speed, acceleration, momentum, and Newton's 3 laws using one of my favorite games, Mario Kart Wii. Let's get started. The formula for speed is distance divided by time. Using the distance and dividing it by the time, you'll find the speed. It usually is measured in meters per second, or miles per hour, in this case, for cars and stuff in the US, or a motorcycle like what we find Funky Kong on here. And if we use the mushroom, we can see that our speed is increased because the distance we traveled, we traveled the distance in a faster amount of time, meaning our speed increased. The formula for acceleration is the final velocity minus the initial velocity divided by time. Here we see I'm at 0 because I'm not moving. And as I go up, we reach our speed. Let's say that our final velocity is at about 80 kilometers per hour, which is standard for a bike like this. And we take that and subtract our initial, which is 0, and divide it by the time, which was a couple seconds. And using that, we can find out what the acceleration was. The formula for momentum is mass times speed. So someone massive, like Dry Bowser, going at 50 miles per hour, will have a certain momentum. Someone like Baby Daisy, who's much smaller, going at 50 miles per hour, her momentum would be much less. But if she were able to speed up enough, her momentum would match Dry Bowser's. Newton's first law states that an object in motion will stay in motion and an object at rest will stay at rest. When I use a mushroom, I'm going to stay in motion until gravity acts on me and I come to a stop, and then once I'm in the stop, I ain't getting out of that. I'm too lazy. That's called inertia, an object's tendency to either stay in motion or to stay at rest. Newton's second law states that force equals mass times acceleration. So someone massive, like Funky Kong, who's using a mushroom, which helps him accelerate, will hit Toadette with a huge amount of force and knock her far away. Someone like Toadette, however, who does not have a very large mass, can't really hit Funky Kong with that big of a force. Newton's third law states that for every action, there is an equal and opposite reaction. So when I hit Funky Kong, the force that I apply to him will also be hit back onto me. So when I run into him, he pushes me to the side. One example of motion is moving forward, speeding up, starting from a standstill and going up. Whenever you're driving, like we are on a motorcycle here, you're always speeding up. That's how you drive. That's what driving is. So, important form of motion. Another important form of motion is slowing down. We always gotta slow down. There could be a stoplight or a little kid in the road trying to get his baseball or something. You gotta slow down. It's an important form of motion. Another important form of motion is backing up. You know, whether you're in your driveway or like a parking spot at the McDonald's, you never know. You gotta back up, go in reverse, and that's motion. That's important motion. Another important form of motion is changing direction. You're always changing direction. You gotta be turning and stuff. Roads aren't straight. You can't teleport. You gotta turn. That's how you drive. You gotta turn. Has to happen. And if you're a rad, super awesome, cool cat, and you have a dirt bike or some form of BMX racing bike or something along those lines, another form of motion could be found on half pipes like this. Gotta go up, gotta go down. If you're in like a competition with dirt bikes or something, there's gonna be ramps. Like here. Gotta go up, gotta go down. It's an important form of motion. To determine if something is in motion, we have to use what's known as a frame of reference. We're going to use the coconut sign on the bottom to see if I'm in motion. As you can see, that is my position relative to the little coconut thing, or whatever. And as I move up, until I move. The coconut thing is way over there. That's the frame of reference. I'm no longer in the same position that I was before. That's how you know that I've moved. That's enough science for today. I hope you all enjoyed watching this. I'll see you next time. Bye. Oh boy, cool glitch!